One of the most commonly asked questions I get about Centroid is about tool height offsets. So if you're going to be machining, CNC machining a part with a program that's using more than just one tool, we somehow have to communicate to the control how much each tool is sticking out of their tool holder, right? Like if you need to use this tool and this tool in your program, the computer doesn't know, or the control doesn't know how much each tool is sticking out. So you've got to tell it that. And it's a simple concept, but the details of it sort of confused me for longer than I care to admit. So in this video, I'm going to do my best to explain exactly how it all works and what's going on in the control when you're setting tool height offsets, how to turn them on and off, and what it all means. And I think the best way to start is to sort of forget all about tool height offsets for just a second. This is a 1, 2, 3 block, which means this edge measures exactly 1 inch, this edge measures exactly 2 inches, and this edge measures exactly 3. So I've set the top of this vice jaw to be Z0 for this tool. So if we go over to the control and we go to our, so this is the home screen in Centroid. Now you see mine has a black background, but that's just because I've changed it. Yours is probably blue. That's okay. All the buttons and things are going to be the same. It just looks a little bit different. So if we go to the MDI down here, this is the manual data input screen. We can go ahead and just start typing G code in here. And so if we go to, we do something like G1, which is a feed move. So let's give it a feed of 10 inches per second. And we're going to say we want to go to Z position 1. We hit cycle start. And we can see that the tool is moving to Z, height of Z1. You can see on the control, we stop at 1 inch. And when we put the block underneath the tool, we can see that it just barely fits under the tool, which means that the tip of this tool is at a Z height off of this Z0 plane of 1 inch. We can do the same thing. We can go G1. Let's move a little faster. Let's give it a feed rate of 30, and let's move to a Z position of 2. Let's hit cycle start. We can see the machine moves up, and now we are exactly 2 inches off the top surface, which is our Z0. Let's go up to 3. Now we can use, instead of G1, we can use G0. This is a rapid move. We don't have to put in a feed rate because our rapids are defined in the control. But let's go up to Z3, hit cycle start. And now we can see that our tool is exactly 3 inches from the top surface. But things get a little different when we change the tool. So let's go ahead and change the tool to our tool number 1. We can see that this tool sticks out a lot less than the chamfer tool that we were using previously. So when we go ahead and say something like bring this to, let's do a G1, feed rate of 30 inches per minute, and let's go to a Z position of 1. When we hit cycle start, the machine is going to move down, and now it is no longer at the top of this block, right? This is exactly 1 inch above our Z0, but we've put in a different tool that sticks out a different amount. And without telling the machine how much more or less it's sticking out, it's not going to be at the top of the block or in the position we need it to be. So now let's talk about this concept of tool height offsets. In Centroid, up here, you see H dash dash dash. There's no numbers here. There's dashes instead because tool height offsets are not enabled. To enable tool height offsets, there's a G code, it's G43. And so let's just go ahead and type in G43 and keep your eye up here on the dash dash dash. We're gonna hit cycle start on G43, and here you go, we have H1 enabled now. If we want to turn off tool height offsets, we just go G49, and now we're back to H dash dash dash, and there's no height offset enabled right now. So I told you that was tool number 1. I do have the tool height offset already set. We're going to go over how to do that, but let's just show what exactly that does. Keep your eyes right here. Like the last thing we told the machine to do was to go to a Z height offset of 1 with that chamfer tool. And then when we put in that shorter tool, it's obviously not going to be at the height we need it to be. So if we turn on our tool height offsets, we go G43. Okay, we're going to turn it on. Now here we are, we're at H1. Now if I wanted it to be, so this is what we have activated right now is the height offset for tool 1. If we wanted to activate the height offset for tool 2, we would type in H2, cycle start, and then you see up here we've got H2. And as we're changing these tools, keep your eye right here on the Z value. So I'm going to go back to H1, okay? You're going to hit enter, and the Z value changes, right? H2, the Z value changes again. Let's go back to H1. And like I said, I've already set the tool height offset. So what the tool that's inserted is H1, and now we are getting a Z height of 1.3791, which means that there's a gap in here of 0.3791, because this is still Z0. So let's go ahead and tell the control to move to a height of Z1 when we have tool height offset 1 activated. And let's see what happens. Okay, so the tools move down, and now we're exactly at the top surface of this 1, 2, 3 block. We're 1 inch above this surface. Let's move to, let's give it a G1 with a feed rate of 30, and let's move to a Z height of 3 inches. Let's hit cycle start. We still have height offset 1 activated. We see that we're exactly at 3 inches off of Z0 with height 1. And when we check with our 1, 2, 3 block, we're indeed right there. The 1, 2, 3 block, the tool is right at the top of that 1, 2, 3 block, just barely. I can feel it rubbing. So that's perfect. Now let's go ahead and change our tool to our tool number 2. Okay, so we've got our tool number 2 installed into the machine, and here we got to be really careful, right? Because this tool sticks out a heck of a lot more. So if we don't have the correct offset set and the machine thinks we got the stubby tool in there, well, we're going to crash right into the bicer. We're going to hit something. So this is my tool number 2. Let's tell the control that we've got tool number 2 inserted. Let's go back to our MDI, our manual data input, and let's say H2, and Z changes to 0.7179. That means that the space between the tip of this end mill and our Z0 is 0.7179. So this 1, 2, 3 block should not fit, which is making sense. Let's move the tool to Z1. And now when we put the 1, 2, 3 block in, we can see that it's right at the top. I can feel it rubbing, but this tool is right at a height of 1 inch. So I think you get it now, whether the tool is long or short, or we just have to find a way to communicate to the machine that that tool is inserted. And now, if we go ahead and decide to turn our tool height offset compensation off with G49, we see here we have H dash dash dash, and the machine thinks we're in a different spot. We turn it back on, G43, and we do have H2 selected. You know, it shows a Z of 1 inch again. So I just want to show you these G codes of turning height offsets on and off and sort of what the consequences are. And this is exactly what we want, right? We have 3 different tools, and when we tell the control which tool is loaded up, it accurately compensates for their heights. And so the question now is, how do we set those in the machine, and what does it all mean? First, let's just go over to the tool offset library. And so tools 1 and 2 are the tools we were using. You can sort of ignore these. In fact, I'll just turn them all into zeros so there's nothing confusing here. This just means I'm going to have to reset my tool offsets later, but that's okay. I'm going to go ahead and save this, get back into the offset library. So we're only dealing, let's turn this into a 0, 2. It's got nothing to do with this video. Okay, so we are only dealing with tool height offsets, right? And we're only dealing with tools 1 and 2. I told you guys that I had them set in the control already. And what I didn't tell you was that that very first tool I had loaded in, which was this chamfer tool, this is actually our tool 0. This is our reference tool, and we're going to explain what that means. But tool 0, you can see in the library, there is no tool 0, but you actually can tell the, we're going to go back to our MDI here, you actually can tell the control. So our tool height compensation is turned off, and if I hit G43 to turn it on, and I say, see how it says H0 here? Well, there's no tool 0, but you can actually force the machine to use height offset H0. And what H0 means is the same as when tool height compensation is turned off, and that you cannot set a tool height compensation for H0. The tool height compensation for H0 is 0, always, like by definition. So if you see here, H0, we're at 2.4123. If I turn tool height compensation off, sorry, I didn't actually turn it off there, G49. I turn it off, turn it on, the Z value doesn't change, right? So whether you have tool height compensation enabled, which we do because we don't have the H dash dash dash. So whether you have tool compensation enabled and H0 selected, or keep your eye here, whether you turn off tool height compensation completely, the Z value doesn't change. That just means that when tool height compensation is off or when tool height compensation is on and you have H0 selected, it's exactly the same. You cannot set a tool height offset for H0 because there's no such thing as a tool 0, right? Like if we go to our tool offset library, there's no H0 here for us to even set. We can't do it. H0 by definition has a 0 for the height offset. And so to set tool height offsets, we have something called a reference tool, which is your tool 0, let's say. So this reference tool, all the other tool height offsets are set from this tool. And so whatever height this tool is, if you have a longer tool than your reference tool, it's going to have a positive height offset. So this is our tool number 2, right? And so if we go to our tool number 2, we can see that it is exactly 1.4123 inches longer than this reference tool. And our tool number 1, which was this end mill, we can see it's actually shorter than our reference tool. And when we take a look at H001, it has a negative value, minus 0.3791. That means that this tool is exactly 0.3791 inches shorter than the reference tool. And that is it. So what you could do is measure your tools. If you had some jig, like if you had like a height gauge where you could measure the height of this tool from like a surface plate or from a flat surface, that's your reference tool. You set your 0 there, then bring the height gauge over and measure the difference. For this tool, you could literally plug that into your tool 1's height offset as a negative number because it's shorter, and you can plug it in there as minus 0.3791. And you can do the same thing for tool number 2. If you took this tool number 2 out of its tool holder and measured it against this tool and noticed that it was 1.4123 inches taller than this tool, then you could literally just plug that value into the height offset for tool number 2 and you'd be done. You'd be off to the races. You have your tool height offset set. And like in industry, this is the way a lot of machine shops do it. They have like little fixtures to where they set the tools in the tool holders, and then they're able to measure how much it's sticking out, and they put their tool height offset into the control that way. But Centroid also gives you a way to sort of do it in the machine. And so a lot of us are probably not going to have these fixtures and jigs and like surface plates or height gauges to measure exactly to the 1,000th of an inch how much each one is sticking out, more or less. So there's sort of a clever way that Centroid's come up with that we can do it in the machine, and that's what we're going to go over next. So let's go over to the tool offset library again, and let's just delete these. Let's put zeros in here because we are going to set these from scratch. 0. Let's save these. So as of right now in our offset library, we have no offsets actually set, and we got to go about setting them up. So we mentioned this concept of a reference tool. For a reference tool, you have to pick something that ideally you're not going to machine with. It's got its own dedicated tool holder, and you just kind of keep it in your tool rack and use it as a reference tool. Because as let's say you get a new tool and you want to set its height offset, you are going to set the height offset of that new tool with respect to something, and that something is this reference tool. So it's a good idea. You could use anything. Like in this example, we're using a chamfer mill, but you could also use like an edge finder. You could use a piece of like bar stock or something and stick it in here. It really doesn't matter. And ideally you don't use it to machine. And the reason for that is because tools wear as you machine with them, and so the height may change a little bit over time, which will throw out the new offsets that you put in. So this is going to be our reference tool. It's in the spindle, and now we have to pick something that Centroid calls a reference height. For me, our reference height is going to be the top of this surface, this 1, 2, 3 block. So let's just go ahead and let's hit ZRef here in the control. When we hit ZRef, it's going to say establish the Z reference. So load the reference tool. Great, we've done that. Jog to the reference position. And so our reference position is going to be, like we said, it's going to be the top of this surface. So I'm going to go ahead and move the tool down until, oh, we went too far. Let's move it up. I usually move in 10,000ths until I get close. And then I switch on the pendant, I switch to thousandths and gonna move down a few thousandths at a time until, ideally 1,000th at a time until, there you go. So now it's, you can sort of get the block in there, but not really. You have hit, you know, the tip of that tool is exactly at our reference surface. So let's go over to the control. We jog to the reference position. That's great. That's the top of that surface. Press F10 to save the reference position, or press F3 to seek to probe. This is if you're using a probe to do it. We're not doing it that way in this case. So we're just going to go ahead and hit press F10 on the keyboard, or you can just hit set. And so keep your eye on this number. We're going to hit set. And see how it changed a little bit? The reason it only changed a bit was because I used it as my previous reference surface. But the point is that this is ZRef. This is where you're setting your reference surface with respect to your Z0. So this is your Z0. This part actually doesn't matter. You know what? Let's not even talk about this because it's sort of confusing. Just know that you have to set your Z reference plane. In fact, it can be something else. Let's just, for the sake of argument, let's decide we want to set our Z reference position as the top of the 1, 2, 3 block like this. Because the reference position can be anywhere, so long as you use the same reference position or reference surface to set up your tools here. Okay, so we're not able to slip it under here. We know exactly the tip of our reference tool is at our reference surface. Let's go back to ZRef. Let's re-update it. We've done all this. We've loaded the reference tool, jog to the reference position, which is the top of the 1, 2, 3 block. We're going to hit set again. Now keep your eye on this number. We're going to hit set, and it's changed, right? And it's changed by about 1 inch. You can see that because we have moved it down. Anyhow, just know you have to set your Z reference position. Now that we've done that, let's go ahead and put in our tool number 1. Okay, our tool number 1 is in. So let's move the tool down until it just, oh, I went a little too far, until we can't, we're moving down in increments of 1,000th. Okay, now we can't get it in. So the tip of our tool number 1 is exactly at this reference surface. We go over, we highlight this H1, the height offset of H1, and then we just go manual measure. So I'm going to click manual measure, but keep your eye on the height offset. We go manual measure, and it updates. So it's updated to minus 0.3787. That means this tool is 0.3787 inches shorter, because of the minus sign, than that reference tool, which makes sense. That's what we had last time. Let's go ahead and load in our tool number 2. All right, our tool number 2 is loaded into the machine. Let's do the same thing. Okay, I'm switching to thousandths and moving down in increments of 1,000th until the block no longer fits. There it is. So now the tip of this tool is exactly, our tip of our tool number 2 is exactly on the top of that 1, 2, 3 block, which is our reference plane. We're going to select this H2 in yellow, and again, we're going to hit manual measure. Keep your eye on this number as I click on manual measure. And we are 1.4122, which is to say that H2 is exactly 1.4122 inches longer than our reference tool that we loaded in first. And this is it. We're done. You go ahead and hit save. And now when you go back into your offset library, you can see that it saves those offsets for tools number 1 and tools number 2. So let's go ahead and prove that we've set these height offsets correctly. Let's go ahead and throw in the reference tool again. Actually, you know what? Let's not do that. I'll show you how to set. So now that the work coordinate offsets are set, we're going to go over to, here's our home screen. We're going to go to setup. We're going to set up our part. So let's go next axis, over to Z. And right now we have tool number 2 inserted. So let's say, okay, we are using right now tool number 2. And let's say we want to set Z0 at the top of the 1, 2, 3 block, sort of when it's 2 inches tall. So let's go up. Okay. Now let's do this again until our tool number 2 is exactly at the top of this 2-inch tall 1, 2, 3 block. There it is. And so let's call this, right now we're setting our work coordinate offset, right? So right now the control thinks that we are 3.4 inches above some 0, okay? But we're going to tell it we have our tool number 2 inserted, and we want the Z position with tool number 2 inserted to be 0 right here. So let's hit set. You can see we've moved to 0, and we have H2 height activated, right? So that means with tool number 2, this part position is Z0. So let's go ahead and let's go over to our MDI. Okay, let's go to our MDI, and let's go G1 at a feed rate of 30, and let's go to a Z position of 1. So in theory, Z should lift 1 inch higher than it is right now. Let's see what happens. Okay, great. And so now Z0, yeah, I can really feel it dragging right here. It barely goes in. We are 1 inch above our Z0, right? Because this was our Z0. Now we're 1 inch above it, and we're proven that we're exactly right there. Let's go ahead and change this tool out. So we got our tool number 1 back in the spindle. Let's go over to the MDI, give it a G0 at a feed rate of 50. Oh, sorry, not this. First we want to tell the machine that to use activate height offset 1. So we're going to hit H1 because we've got tool 1 loaded. And then now we'll go G1 at a feed rate of 50, and we will go to Z1. And we will go ahead and hit enter. And so now this tool should be exactly 1 inch above the top of the 1, 2, 3 block when it's in the sort of 2 inch orientation, because this is the 0 that we set. When we go to 3 inches, we can see that, like, it's sort of hard to get in there because it's right at the height of it. But you can see it's all working now, right? Like, we have set our tool height offsets. When we load in the different tools and we tell the control which tool is inserted, we are exactly where we need to be. And now we could run a CNC program with tools number 1 and tools number 2, and the program will finish sort of without anything crashing, provided you've written the program right. But now the CNC control knows exactly where the tips of tools number 1 and tools number 2 are. So let's take it a step further. Like, great, we've learned about tool height offsets and how to set them, and activating and deactivating tool height offsets with G43 and G49. But how does all of this apply to a CNC program? Well, the good news is all of that sort of happens automatically in the background. So here's like a little adapter plate that I've been making for a floodlight that I just installed. But the point is so here we're doing work with tool number 2. We're coming in and doing a bit of an adaptive strategy with tool number 2. We're doing another adaptive with tool number 2, coming in and cleaning things up. We got more tool number 2, but then we switch to tool number 11. So let's post this code and see what it looks like. Okay, so on the right here, this is the actual G code that we just posted for all of these machining operations. And this is just using Notepad on my PC. You should really use something better like Notepad++, which will sort of format things a little differently and change the colors of things so that it's easier to read. Because this is mostly something that's kind of very difficult to read. It's many, many lines. So just to do everything in job 1, which is like all of this stuff, this is how many lines of code you're actually dealing with, right? So you can see there's over, well, the lines move in increments of 5. So we're not exactly at 20,000 lines here, but we are at 32,000 lines divided by 5. So 32,000 divided by 5 is 6,400 lines of code to get this thing machined. But so it's a lot of code. It's mostly difficult to understand and hard to read, but let's take a close look at the first few lines. So the way this program starts is this 2D adaptive 1 with tool number 2. So let's look here. Okay, so tool number 2, which is a bull nose end mill. This is 2D adaptive 1. But let's look at some of the G code here, okay? Mostly, I don't know what any of this stuff means, guys. There's a lot better programmers and CNC guys here that would be able to tell you exactly what all of this stuff means. I cannot tell you what it means because I don't know. But what I can tell you is that, look at this right here. Okay, G43. Before we start machining, G43, this is activating height offset for tool number 2. So we were doing it manually in the MDI, but all of this happens automatically. So let's go to the very bottom because drilling sort of doesn't have as many lines of code. Here, okay, I see a manual tool change to T8. That's because the very last operation is drilling for tool number 8. Let's see if we can't see a tool 11. Here we go. Here's the first drill 1. So that is this drill 1. And where is our tool number 11? Here it is, G43. It is activating height offset 11 for our drill number 11. Then we go a little bit further. It is activating height offset. Here you go, G43, activating height offset 8 for tool number 8 over here. So all of this happens automatically in the post processor. The G code is generated, but that is what the G code is doing, right? So it took me a little while to understand this and, you know, understand the concept of G43 and G49. So the good news is if you follow this video a little bit, you will probably still be able to get up and running and machining. Like even if you don't fully understand what G43 and G49 do, it all happens automatically in the code in the background. So if you're able to set your height offsets, whether you measure the tools like we were talking about, or if you use that sort of process that's available through Centroid where you load the reference tool, touch the reference surface, and then touch the other tools to that reference surface while hitting manual measure. If you can set the tool height offsets in the control, however way is most convenient for you, you can literally write a program, or not write a program, but you can program a part in CAM, and then when you post-process the part, all this G43 stuff happens in the background. But I hope this video was able to clear some of the confusion with tool height offsets and what exactly is going on in the background and how it sort of works with Centroid. If I've missed something or something wasn't super clear, please do let me know down in the comments and I'll do my best to clear things up. Thanks for watching, guys. Have a good one.